Hey everybody, and welcome to this video. I'm going to show you how to create an arc to display the trajectory of a projectile. Now you could use this for throwing grenades or launching arrows or really anything that you like. And as soon as you launch an arrow, you can see where it's going to end up. So this is a great way for us to know what we're going to hit and also see that path. So it's a little bit more dynamic and interesting than just crosshairs on the screen. So notice I used to have crosshairs. I'm just not showing those crosshairs at the moment. I now have this path. Now I've set it up so that I can change that speed of my projectile, and this could be set up later so that you could have a long draw of the bow, and that parabola, that arc, will reflect that arrow's path. So if I take my arrow speed and I turn it down a bit from 4,000 to 2,000, then my arc will reflect that. So this is something that we could change dynamically, and I'll show you how to do that. So this can be extended to any number of applications. So let's go ahead and get started. This video is made possible by the following patrons. Shout out to new patrons: Nolan Zink, Matthias Pearson, Small Gumball, Johnny Machoni, Michael Hutchkins, Kristen Morton, Dreamcraft, Rajesh Iyer, Raphael Sangalis, and Pew Pew. Thank you all for the support, and if you'd like access to these videos a day in advance, join my Patreon. A link will be in the description below, and you can also gain early access to my new Unreal Engine 5 course, Unreal Engine 5 C++, the Ultimate Game Developer course, where you'll get to learn all sorts of new Unreal Engine 5 features, including how to make an open world map with world partition. We're going to cover combat, some RPG mechanics, all sorts of great stuff. So this is quite the remaster of this Unreal Engine course. We'll make a complete, realistic open world from scratch with landscapes, foliage, painting, the whole 9 yards. Actually, this level is a great deal larger than 9 yards, and I'll teach you all the basics of Unreal Engine 5 C++, and we're making this project from scratch. So join my Patreon if you'd like early access to this, and you can start watching these videos as I complete them, so you're getting access to this well in advance of anyone else on the internet. All right, so let's get started with this projectile path. Now, my goal here is to draw this arc, right? And it's going to need some setup. In fact, what I'm using here is a spline component and a spline mesh. And a spline mesh is essentially a mesh that can be deformed using points along a spline. So this means I'm going to need a mesh to use for this projectile path, as well as a material. Now, the place I'm going to get these is from this old VR template project from Unreal Engine 4. It has a nice cylinder that I can use for a projectile path, as well as a blue material that I can steal. So it's here in this project. It's called Virtual Reality. If you join my Patreon, you'll have access to a project that contains these assets. So what I'm interested in here is this nice glowing material. I can open it up and see what it looks like. It's sort of transparent and blue, and we can change the color, of course. And there's also a beam mesh, which is really tiny. It's this cylinder. It's one-sided, so we can't see the inside of it, but it's basically all that we need for an arc or a projectile path. So I'm going to want to migrate these over to my project. But before I do, this cylinder is a bit too small. I think I need to scale it up by a factor of about 5. So what I'm going to do is get that into Blender and scale it up. So I'm going to right-click on my beam mesh, go to Asset Actions, and I'm going to simply export this as an FBX. And I'm going to find my project. Here it is. And I'm just going to make a new folder here called Assets. And I'm going to export this beam mesh into that Assets folder. Now, I don't need the collision. I don't need level of detail. I'm just going to export the mesh itself. I'm going to open Blender and import this mesh in so I can scale it up. So I'm going to go to Import FBX. I'm going to find my project, Go into that Assets folder, get that beam mesh, and import this FBX. Now, if I zoom in Blender, I see that it's really, really tiny. Now, zooming in Blender is pretty easy. I'm just holding Control and clicking and dragging my middle mouse wheel. And if you'd like to learn Blender, you can take my Blender course, which is coming soon. I'll be announcing it, so go ahead and subscribe to my channel if you'd like updates so you can know when that course is coming out. Now, I'm going to take this mesh here, and I'm simply going to scale it up probably by about a factor of 5. So I'm going to hit S to scale, hit 5, enter, and that's going to do it for me. So now that this mesh is 5 times bigger, I can export it. So I'm going to go to File, Export, choose FBX, and find my project, go into the Assets folder, and I'm going to call this, I'll call it SM for Static Mesh, Beam Mesh. So I'm going to export that FBX and get this back into my project. So before I do that, I do want those materials, so I'm going to go ahead and get this whole folder filled with these materials. I'm going to right-click on it and migrate this over to my project. So here's my project. I'll go into my Content folder and simply move this over. Now I'm done with that old project. I'm done with Blender, so I can get my project back open. And now I should have a virtual reality folder that just has these materials in it. And I can double click just to preview one of them. There it is, looks great. Okay, I'm gonna dismiss these pop-ups here. And I need to get that new cylinder mesh into my project. So I'm gonna go into my content folder and simply make a new folder called Arrow Arc. And here in Arrow Arc, I'm just going to import that mesh. So I'm going to click Import, go to my Assets folder to get that static mesh called Beam Mesh, and import it. Now, I don't want to create new materials, so I'm going to select Do Not Create Material and Import. And here's my beam mesh, and it's scaled up quite a bit, and it's still pretty small, so that's why I needed it a little bit bigger. So now that I have the beam mesh, I can go to work on this arc system. So the first thing I'm going to do is take a look at my project and see what it looks like. I have my arrow character. I can use my aim offsets to aim in any direction, and I'm going to want my arc to sort of follow the direction of my arrow. Now, in the last video, I set this up to use an animation layer interface, and now I'm noticing if I aim to the side and I shoot, I sort of shoot that arrow using the animation montage without that aim offset applied. So I'm going to want to fix that really quick by going into my animation blueprint. So finding my animation blueprint, I have several that I'm using, but my main one is ABP Archer. And the reason I'm getting that montage played without that aim offset applied is because I'm doing the aim offset first. So what I want to do is do the aim offset after I do a layered blend per bone using the slot that my montage is using. So really, I just want that montage right here after applying that slot. So here's what I'm going to do. I'm going to move that aim offset down here. And now this cached pose shouldn't be called aimed offsets. I'm going to rename it to simply ground locomotion. And now that I'm applying the aim offset after the slot, I should see that aim offset applied as it should look. So we're firing the weapon, the aim offset looks good. All right, so now that I got my project in a good working state, I want to show the trajectory of my arrow. So basically my arrow is flying in an arc. You can't really see it with a high velocity, but when gravity is applied, things fly in an arc. And to visualize an arc, I can use a handy blueprint node called Predict Projectile Path. I'm going to do this in my character blueprint. So I'm going to go to my character blueprint here. And when I fire my arrow, I'm doing a few things. I'm tracing out from the center of my screen and getting an impact point. Here's my line trace here. I'm tracing out, getting an impact point, and that's going to help me determine where I should point my arrow when I spawn it. Then I'm spawning an arrow and I'm setting its transform, and that arrow has a projectile movement component. So really all of these things that I'm doing here, I'd like to refactor them into a function so that this graph doesn't look too out of hand. So here I'm getting a start and end location for a line trace, And here I'm performing the line trace, and I'm setting a spawn location and a spawn rotation for my arrow. And you can watch the previous videos in this series to find out how to do that. So I'd like to refactor some of this stuff into its own function. So right here, I'm setting a start and end location for a line trace, simply getting my player camera manager, getting the location of that camera, getting the forward vector, and setting a start and end location for a line trace. I'm going to collapse this to a function called getStart and end for trace. So now that looks a great deal more organized. And the next thing I'm doing is actually performing the line trace, and I'm setting my arrow spawn location and spawn rotation. So I'd like to get these nodes here and collapse them to a function. So I'm going to right-click, collapse to function, and call this one getArrow spawn location and rotation. A nice long function name, but hey, it's descriptive. So that's the first two things I'm doing. After that, I'm actually spawning my arrow. I can move that up so this looks a little more compact. And finally, I'm playing a montage up here. So playing this animation montage is something that can't be put into a function, but that's okay. I don't need to. Basically, I have all the important stuff here. And really, these two functions could simply be their own single function. We're getting a start and end for a trace, and we're actually doing the trace to get that arrow spawn location and rotation. So I think I'll go ahead and make another function where I just call these two. So I can simply break this and call these both in sequence and collapse this to a function and call this trace for arrow. So that's basically the trace that we're doing for our arrow. And now this sequence doesn't need all of these execution pins. I can simply use the 1 to spawn the arrow and the 2 to play the montage. So we're doing three things. We're tracing, I'm spawning an arrow, and I'm playing an anim montage. So I can remove that third pin. Okay, so there's a reason I'm doing all this, and that's because I'm tracing for the arrow only when I fire my weapon. Now I want to do this every frame so that I can have a starting location and rotation, not only for my arrow, but for my arc, for my path. And that's because a projectile path needs to know a direction and a speed to simulate the launching of a projectile. So let's see how this works. So just under my input action fire here, I'm going to use the tick event. So I'm going to get tick right here. And here in tick, I'd like to do my line trace to get that arrow spawn location and rotation. So I'm simply going to call that here every frame. And now that I'm calling it every frame, I really don't need to do it in my sequence. So my sequence can actually be even simpler. I can just spawn an arrow and play a montage. So I could reorganize these, or I could just make a new sequence and remove this one. So now I just have a sequence with two cases, one to spawn an arrow and the other to play a montage. And now every frame I'm tracing for my arrow. So basically what I'm doing here in trace for arrow, the most important thing here is I'm calculating my arrow spawn location and my arrow spawn rotation. So I'm still able to spawn arrows. I'm just performing that trace every frame now. And that's going to allow me to have an arrow spawn location and rotation for my arc. So I'm going to get that arrow spawn location and my arrow spawn rotation because I'm going to be using those. Now, to predict a projectile path, I can simply use the predict projectile path. And we have several versions. We have by object type, by trace channel, and advanced. If I select advanced, this function simply takes a structure called predict params. And I can drag off of predict params and select make predict projectile path params. It's basically this structure with lots of variables inside of it. So I can predict a projectile path here based on a start location. We're essentially simulating what a path would look like for a projectile starting at this start location. That's why I want my arrow spawn location. And we also have a launch velocity, which is the direction of my projectile. But it's also important what the magnitude of this vector is because that's going to determine our projectile's speed. So if I get my arrow spawn rotation and I use get forward vector, this get forward vector gets me a vector based on this rotation value, and I can multiply this by a float value to get a vector in the direction of my arrow projectile scaled by its speed. Now my arrow is a blueprint. Right here, it's an actor, and it has a projectile movement component with an initial speed and a max speed, both set to 6,500. That's how fast my projectile is moving. So if I want this projectile path to be accurate, then its velocity needs to be a vector with a length of 6,500. So I can scale it by 6,500. So I can multiply x, y, and z by 6,500. And now this vector will have the correct length, which means my projectile path will be predicted for a projectile with this velocity and this direction. Now, if I trace with collision, I can trace up to a point where this projectile path hits something. So I'm going to check that checkbox. And we have a projectile radius. Now, we're doing sphere traces along a projectile path. That's why we have a radius. So I'm going to use spheres with a radius of 5, and max sim time is how long we would like this projectile path simulated. Essentially, we're simulating a projectile flying for this period of time. So if I increase this to, say, 5 seconds, then we'll simulate for a projectile that would fly for 5 seconds. Now, if we're tracing with channel, then that means we're going to get a hit result with our projectile path. So I can set that to visibility, and now we'll trace with these spheres against the visibility channel. Now, if I expand this, I have more parameters here. I have an array of actors to ignore, and I'd like this projectile path to ignore my character itself. So I can get a reference to self, and this actors to ignore has to be an array, so I can take self and make an array and hook that array right in. So this is an array with only one element that's a reference to this character. Now, sim frequency is how accurate do we want this projectile. A simulated projectile is really just a series of line segments, and the sim frequency determines how frequently we'll have line segments along our projectile. Now, there's an override gravity z. We can leave that as is, but the draw debug type allows us to see our projectile. So if we choose for one frame, then we'll draw those debug spheres for the sphere trace along this projectile path. And that's going to allow us to visualize our projectile. So essentially what we're doing every frame is predicting a projectile path, and since we're drawing the debug spheres for it, we should see this. So let's see what this looks like. I'm going to go ahead and press play. And here's our projectile path. So you can see what I mean by a projectile path being a series of lines. It's basically a line from one sphere to the next, and we get a red sphere when we're getting a hit result from this projectile path. So it's a lot like a line trace, only it's shaped like an arc. And we can really see this if we change that velocity. Instead of 6,500, we can change it to, say, 2,000. So I'm scaling that forward vector by 2,000 in x, y, and z, and now you can see that my parabola or arc is a little bit more arced. Now, because I changed my predict projectile path velocity, it's not matching my arrow's velocity, so if I shoot an arrow, it's not going to end up at the correct location. But since that value is 6,500, I can set it to the correct value here as I'm scaling that forward vector, and I will see my arrow end up in the correct location as indicated by this projectile. So that's one issue, is we want to be able to change that velocity of our projectile path. We don't want to hard code a 6,500 here, but then in our arrow have a 6,500 there. So that's an issue, and we really want that to be more dynamic. We want to be able to choose a value from our character blueprint so that we can see the projectile path for that, but we also want to launch the arrow with its projectile movement component having the correct value for its initial speed, so that speed will match with the projectile path. So how do we do that? That seems like a tricky thing to try to do. Well, First of all, we're going to want a variable on our character for the speed here. So I'm going to add a new variable, and I'm going to call this arrow speed. And I'm going to change its type to a float. I'm going to compile and give this variable a default value. I'm going to start it off at 6,500. So essentially, if we change this value, we're going to want that projectile path to show a path with that particular speed, but we also want to launch an arrow at that speed. So that means I should go to my arrow blueprint, and our arrow should have its own speed variable. So I'm going to add a variable called speed on my arrow blueprint. It's going to be a float. Now I want to be able to set this as soon as I spawn an arrow, but if I set it after I spawn this arrow, that'll be too late. The projectile will already start moving, and the projectile movement component only uses this initial speed. So if we change it at runtime after we spawn the actor, that's too late. Whatever the speed value is here in the projectile movement component, that's the speed that the projectile will have. We need to set this value earlier. So for that reason, I'm going to select my speed variable, and I'm going to choose to check instance editable and expose on spawn. By checking expose on spawn, then when we spawn this arrow, there'll be an input pin in that spawn actor node that will allow us to set this value for speed. Now, as soon as we set that value, we want our projectile movement components initial and max speed set. And we can do this in the construction script, because if we spawn the arrow and set its speed as soon as we spawn it, then the construction script will actually kick off. So we can get our projectile movement component and call set initial speed as well as set max speed here. So we can call this here in our construction script, passing in the value of our speed, which we just created, and we'll set this when we spawn the arrow. So let's compile and save that and go back to where we're spawning the arrow. So here in my spawn actor here, we're not going to see it. I need to create a new spawn actor node. So I'm going to get spawn actor from class. And as soon as I choose the class, selecting BP arrow, now I see that speed as an input. So I can pass in the speed here. So I'm going to use this new spawn actor from class node instead of my old one, but I do want my collision handling override set to try to adjust location but always spawn. So I'm going to select that and delete that old one. And I was setting my owner and instigator to self here. I'm going to still do that, but now I want to set that speed to my character's arrow speed variable. And I'm still using my arrow spawn location and rotation in this transform. I'm going to hook that in. And now I'm spawning an arrow, setting its arrow speed. And now I can use this arrow speed in my predict projectile path. I don't have to hard code 6,500 as I'm multiplying this forward vector for the arrow spawn rotation. What I'm going to do is right click on that input and split the struct pin and hook in my arrow speed for X, Y, and Z. So I'm going to get that and plug it in for X, Y, and Z. And now I'm scaling this forward vector, which I'm passing in as the launch velocity for my projectile path. So now we have one single variable that we can change here on the character, and that's going to drive my projectile path as well as the initial speed for my spawned arrow. So if I compile and press play, I'll see that my arrow will always hit where my projectile path is predicting. And I can prove this by going to my character blueprint and changing the arrow speed to, say, 1,000 and pressing play. And now I see that path is showing a more droopy arc. And if I launch an arrow, well, we'll see that the arrow follows that path exactly. So that's perfect. Now we have something a little more dynamic. And if I have, say, an arrow drawing animation where I'm drawing that arrow back really slowly, then we can change the value of that arrow speed as we're drawing that arrow back, and it'll reflect how far our arrow would go if we actually launched it at that point in time. Okay, so that's looking good, but one more issue I'm going to show you is that if I look up to the sky, notice I have this jerk. And that's because the endpoint that I'm calculating for my arrow to fly towards is based on a line trace. And we can demonstrate that by going back into where I'm doing my line trace. So now I'm doing that line trace in my trace for arrow function, and I'm actually doing the trace here in get arrow spawn location and rotation. Here's my line trace, and I can set the draw debug type for this to for one frame, since I'm now doing this line trace every frame. And there's my line trace, and I'll see that as soon as I go up to the sky, that's when I get that jump. And I don't like that, so instead of having our arrow spawn location and rotation set directly, I can interpolate. So in this function, as soon as I do my line trace, I'm setting arrow spawn location and arrow spawn rotation. I'd like to rename these to target arrow spawn location and rotation. And that way, these will be targets to interpolate too. So here's my arrow spawn location. I'm going to rename it to target arrow spawn location. And I'm going to get my arrow spawn rotation and rename this to target arrow spawn rotation. And nothing has changed except the names, but now I can interpolate towards these locations and then use that interpolated value. So I'm going to do that back out in my trace for arrow. And I have these target arrow spawn location and rotation variables. I'm going to want two more variables, one for the actual arrow spawn location and one for the rotation. So I'm going to add a new variable called arrow spawn location, and that's going to be a vector. And I'm going to add another variable called arrow spawn rotation, and that's going to be a rotator. And I'm going to simply use vinterp2 to interpolate my vector. So vinterp2, my current is going to be the arrow spawn location. The target is going to be target arrow spawn location. And I'm going to move these forward a bit. And for delta time, I'm simply going to use get world delta seconds. That's an easy way to get delta time. And this interpolation can be quick. I'm going to set it to 30 and use the result of this to set my arrow spawn location. So a basic interpolation here. I'm going to do the same thing for my arrow spawn rotation. I'm going to use rinterp2 since these are rotators. My current will be my arrow spawn rotation. The target will be the target arrow spawn rotation. I'm also going to use get world delta seconds here, and my interp speed will also be 30. And I'm going to use the result of this to set my arrow spawn rotation here. So now I have these two new variables, arrow spawn, rotation, and location. We're still using those old target values that I renamed, and I'm using them when I spawn the arrow. So I can go back to my event graph, find where I'm spawning my arrow. I'm using target arrow spawn, location, and rotation. Now I can use those interpolated values, arrow spawn location and arrow spawn rotation here. So I don't need to use those targets anymore. Those are just for interpolation. But I'm also using these down here when I make my projectile path. So instead of using the target values, I'm going to use arrow spawn location here for the start location, and I'm going to use arrow spawn rotation here and hook that in. So now I have these values interpolated, and if I press play now, then when I line trace up above the wall, we do get a change, but it's not snapping. It's now interpolating smoothly, so we won't get any jerkiness in our projectile path. So that's looking great. Now I don't need that debug drawn for my trace, so I can go back to trace for arrow, which get arrow spawn location and rotation is where I'm actually doing the trace, and change that debug type to none, and now I don't see that debug for my trace. Okay, so now that that's taken care of, we have a parabola, and we can change our arrow velocity, and our projectile path is going to accommodate for that as well. Now we need a spline mesh for this projectile, because we don't want to just use debug spheres for our projectile. Right here, we want to use an actual spline. So how do we do that? Well, we're going to need a spline component. So I'm going to click on Add in Components and search for Spline, and select Spline. And I'm going to call this Arrow Path. Actually, I'll call it Arrow Path Spline. Now, as soon as I added a spline component, if I go in the viewport, I can see it right here. And by default, it has a couple of points to it. Now, these points can be edited directly, and you'll see that what a spline is a series of points connected by a line, and those points have their own rotations and locations. And by changing them, we get a smooth line from point to point, and we can add points and we can remove points. We're going to want a point on our spline for each of those spheres in our projectile path. And that way we'll have this spline going along this projectile path, passing through each of these points, and it'll be smooth. So let's learn how to do that. So back in my event graph, I'm going to take my predict projectile path node, and notice that it returns a predict result. So I can drag off of that predict result and break that. It's a struct. And notice it has this path data, which is an array. And if I drag off of path data, I can loop over it. So I'm going to use a for each loop. And for each element in this path data array, we have a predict projectile path point data structure. And if I drag off of that and break that, now we have a location, a velocity, and a time. Now the time is the time along the projectile path. This isn't actually the amount of time that our arrow has been flying. It's not like that. It's the simulation time for our projectile path. This path has been simulated in the space of a single frame, but it's simulating a projectile that would be flying for a specified amount of time. So each one of these points on this path corresponds to a simulation time for that projectile, but we don't need that time. We just care about the location. So what we want to do is for each path point in our projectile path data, we want to add a point to our spline, but we're doing this every frame, and I'd like to remove all the points from the spline every frame before we start adding points for each of our path data values. So we actually need a function to clear our spline first. So we'll make a new function here, and I'm simply going to call this clear arc. And this clear arc function is going to take our spline, our arrow path spline, and simply clear its points. We can do that with clear spline points. So calling clear spline points will remove all the points from our spline. We're going to do this first before we start adding points to it. So in event tick, after we've already traced for our arrow values, we're going to call this new function clear arc before we start adding points to our spline. And this will clear our spline. And now in our for each loop, we can add points to our spline. So we're going to take our arrow path spline here, and to add a point, we simply call add spline point. And we're going to do this in our loop body. So for each path data point on our projectile path, we're going to add a spline point to our spline. And add spline point takes a position. That's why we want to break that predict projectile path point data struct to get that location for it, and we can set that here for our add spline point. And we're going to set this to world space, and we'll leave update spline checked so that way our spline will be updated. So let's see how this looks. I'm going to press compile, hit save, and go back and press play. And we can't see our spline, but if we hit tilde and type show splines, enter that console command, now we can see our spline. Now it might be a little hard to see, so I'm going to shift F1 to get my mouse cursor, click eject, and go up to my projectile, and check this out. Here's our spline. It's the white line, and we can see the spline points at each of our debug spheres for our projectile path. So we have successfully created and updated our spline, and it goes all the way to that final projectile path point where we get our hit result. That's why it's red there. So if we go ahead and possess our character again, we see that we're doing this every frame. We're updating that spline. So we're clearing it, removing all the points, and then adding a new spline point for each of our projectile path points. So that way our spline matches our projectile path. So essentially we predicted our projectile path just to get those locations for a projectile path. And then we use those locations to add spline points. And we want this spline because we're going to want to add a spline mesh to this spline. And that way we can have our cylinder going along the spline and deforming appropriately. Now, before we go and add that spline mesh, I'd like an endpoint for this arc. I'd like to show like a sphere or some sort of mesh at the endpoint for my projectile path. Now, that's going to be pretty easy, so I'm going to set that up now. First, I'm going to add a static mesh component. So I'm going to add a static mesh. I'm going to call this arc end sphere. And this can simply be a sphere. I'm going to search in the static mesh for sphere. And I'm not going to use shape sphere. I'm going to use material sphere. That should be built in to the engine. And I'm going to scale it down by about 0.3 in X, Y, and Z. So we have this little gray sphere, but I can change the material. And I just migrated some materials. They're in my virtual reality materials folder. I have M Spline Arc Mat. This is a nice material that is kind of dynamic. It's got blue and light blue sort of alternating. I'm going to use this material. So I'm going to get my M Spline Arc Mat, go into my third person character and drop that in. And now we see what that sphere looks like. And I'd like to set this at the endpoint for my projectile path. So I'm going to go back to my event graph. And as soon as we're finished with this for each loop, we now have a valid path. And I'm going to want the location for the very end point in my spline. Really, I can get it from my predict projectile path result because we have this path data. And if I drag off of that path data array, I can get the last index, which will tell me the last index in the array. And I can also get this path data array and use get. I can get a ref or a copy. I'm going to get a ref and use this last index to get the very last element in that array. And from that last element, I can break it. So break predict projectile path point data and get its location. And I can simply promote this to a variable. And I'm going to call this variable final arc location. And now I know the final arc location, and I'm going to set this at the end of my for loop. So as soon as it's completed, then I'll set that final arc location. And now I can use that to update that sphere right here. It'll be at the very last arc location. So I'll go ahead and get my arc end sphere, and I can call set world location, and I can pass in final arc location. And if I do that and press play, now that sphere is at the final arc location, and it apparently has collision on it, which is kind of cool, but not exactly what I wanted. So because I'm knocking around things that have collision enabled, I'm going to want to set that arc end sphere to have no collision. So I'm going to select it and scroll down to collision, go to the collision presets, change it to custom, and change collision enabled to no collision, and ignore all channels. So that way I won't actually be knocking things around. It'll actually just stop on anything that it hits. So now I have an endpoint for the arc. Now I need the actual arc spline mesh itself. And I mentioned I wanted to make a function for this arc end sphere. So I can do that. I can also abstract this all into its own function, as this is getting a little bit out of hand. So what I'd like to do is make a couple of functions here. For one, I'd like to predict the projectile path in its own function. And I'd like to return the predict projectile path result as an output parameter for that. So I'm going to make a new function, and I'm going to call this simply projectile path. And I'm going to add an output to this. And the output type should be this type, predict result. It's a predict projectile path result structure. So I'm going to go ahead and add that output. It's going to be a predict projectile path result. So now we have a return node, and we'll call this path result. And we can do all of our predict projectile path stuff in here. And then we can take care of adding all the spline points after that. So I'm going to organize this so I can highlight my predict projectile path, highlight them and copy. I could have just collapsed them to a function, but I'm going to paste them right here into my new function where all I'm really doing is predicting the projectile path and returning the predict result. And now in the event graph, I can simply call that function projectile path. And I can use my predict result now and hook that into my break predict projectile path result, and I can remove these nodes. So my projectile path is all done in this function. Now just compiling and pressing play, I want to make sure that it still works, and it does, so that looks great. Now after the projectile path, we're adding all the spline points, and we're setting the final arc location. I'm going to make a function for this as well for updating our spline. So I'm going to highlight all these, right-click on them, collapse to function, and call this update arc spline. And we'll handle all that spline stuff in update arc spline. Now, so far, all we're doing is taking that projectile path result and looping over it and adding a spline point for each location. But I'm going to want to add some spline meshes as well. Now, before we go and do that, I do want to make sure to set the spline point type for the very last spline point in my spline. So what I'm going to do is just after adding the spline point here, I'm going to get my arrow path spline, and I'm going to call set spline point type, and I'm going to call this set spline point type on the very last, and I can do that because I have the last index in this predict projectile path result. So what I'm going to do is get that last index and hook it in here. So I set that last spline point type, and I'm going to set that type to curve clamped. And that way we won't have our tangent affected on that last spline point. And I'm going to do that when this for loop is completed. So I'll actually hook that up here, and then we'll finally set the final arc location there. Okay, so that's one thing. Now another thing is, as soon as this for loop is done, we're going to want to add those splines. And in order to add the splines, I'm going to want to loop over all of my path points. So we're going to have a second for loop. Now it's not going to be a for each loop, it's going to be a regular for loop. So we'll have for loop, and this way we can specify the first and last indices. And the reason I want a regular for loop is because I want to loop over all of the spline points except for the last one. So if I wanted to loop over every single spline point, including the last one, then my last index would be my number of spline points minus 1. And I can get that by getting my arrow path spline and calling get number of spline points. And if I subtracted 1 from this with a minus node and hook that into the last index, then I would loop over all the spline points because we're starting at 0 and we'll end at the number of spline points minus 1. But I want to end at the second to last spline point, and we'll see why in a minute. So I'm actually going to subtract 2 from this. And this for loop is what I'm going to use to add spline mesh components. We can add spline mesh components by simply calling the actor function add spline mesh component. And this function has some things we can set in the details panel, such as the static mesh for a spline mesh component. So we're going to want that cylinder. So I'm going to search for SM, and it's called beam mesh. I'm going to choose that, and we can also choose the material for this. And I want my M spline arc mat. So I'm going to browse to that and drag it in and dump it right there. So we're adding a spline mesh component, but we're doing this in a for loop for each point in my arrow path spline. So I have all these spline points. We're looping through for each one except for the last one. That's why we have the -2 there. And we're adding a spline mesh component. Now I'd like to store these spline mesh components in an array. So I'm going to make a new variable for this. So I'm going to add variable, and I'm going to call this spline meshes. This is going to be the type spline mesh component. That's actually what gets returned from add spline mesh component. Only I'd like this to be an array. So I'm going to go to the details panel, click the drop down and select array. and I'm going to add this spline mesh component to my array. So each time we make a new spline mesh component in our for loop, we're going to add it to our spline meshes array. So I'm going to get spline meshes and simply use add, and I'm going to add the return value from add spline mesh component. So now we're adding a spline mesh component, but we do need to set some properties on the spline mesh component. Notice the spline mesh has a start position and an end position. It also has a start tangent and an end tangent. That's basically a vector that determines its direction. These spline meshes are going to be warped along the spline, which means we need to set how those spline meshes will be warped. So we can do that by getting our return value from add spline mesh component and calling set, start, and end. And this allows us to set the start position, start tangent, the end position, and the end tangent. So we're going to set all of those. And we need to do those by accessing spline points. So our for loop has an index, and we can grab that index and we can access spline points on our arrow path spline by index. So I'm going to get my arrow path spline and call get location and tangent at spline point. And this takes a point index. So for each point that we're looping over, and we're looping over all but the last one, we can get that location and tangent. But we can also get the location and tangent of the next one. This is why I'm looping over all but the last element, because we're going to get the current and the next one, each iteration of the for loop. So I'm going to copy that, hook in my arrow path spline, and for my point index, I'm going to get this index from our for loop, but I'm going to add 1 to it. So let's add 1 and hook that in for the point index. So what we have here is location and tangent information for each point in our spline and the next point as well. So looping over all but the last one ensures that we don't try to get the next point when we're already at the last point in our spline. And we can get this location and tangent for the current point in our loop body and set our current spline mesh we just added. We can set its start position and start tangent. We're going to hook those in, and we can set its end position and end tangent to the next spline point's location and tangent. Okay, so a little bit complicated, but really all we're doing is we're adding spline points for each point in our projectile path data, and then we're looping over the elements in our spline itself and adding a spline mesh component for each of those. But we're adding spline mesh components like this every frame, which means we should clear them every frame at the very beginning. So we can go back to our clear arc function and simply destroy those spline meshes because we're going to create new ones. So every frame will destroy our spline meshes. So we'll get spline meshes, and we're going to call destroy component. I can't do it on an array, but what I can do is call destroy component and get any one of these. And instead of, say, camera boom, I can simply plug in my spline meshes array just like that. So you might not have known you could do that, but you can plug an array of spline meshes into destroy component, and it'll go ahead and loop over that spline meshes array and destroy them all. Now, as soon as we destroy each component in spline meshes, we want to empty that array as well. So we can take that array and call clear. And this will make sure that we're not trying to access any elements that have had their spline mesh components destroyed. All right, so back to the event graph. One last thing is we want to go to update arc spline and make sure that add spline mesh component has manual attachment checked, and that way this function won't attempt to attach our spline mesh component to anything, as we don't want that. So let's go ahead and press play. And there's my spline right there. So it's not quite at the right location there. And that actually looks like we have a discrepancy between probably local and world space, because our projectile path is correct. It's the spline mesh that is not correct. So let's go back to update arc. And here where I'm adding a spline point, I'm going to set coordinate space to local, and we'll see how that works. And sure enough, that looks good. In fact, it looks great. And since I no longer need to show those debug spheres, I can remove those from Predict Projectile Path. So I'm going to go back to my event graph. Here's my projectile path function where I'm predicting a projectile path. I can change draw debug type to none, and now if I press play, I just get the projectile path. And I can launch an arrow, and it'll always hit where my projectile indicates. Now, the cool thing about this is we made this dynamic so that I can change my arrow speed here. So if I change the arrow speed to 6,500 again and press play, then not only is my projectile path showing that, but my projectile itself is flying at that speed. So this is great. If you wanted to update that arrow speed dynamically, you could do that. And just to really briefly show how you can do that, I'm going to take my arrow speed and set it to 0, and then every single frame in event tick, I'm going to add 1 to it just to show that arrow speed is dynamic. I'm going to set arrow speed equal to arrow speed plus 1, and we'll go ahead and set that arrow speed here in tick. And that way, if we press play, we'll see that it's growing. And as we launch arrows, those arrows are flying along that spline point. So this is something you could use when drawing an arrow back, and you could maybe create a timeline where you're changing that arrow speed dynamically, and the projectile path and the arrow itself are going to both be congruent with one another. So that's great. So I'm going to go ahead and set that arrow speed back to, let's set it to 5,000. And we have a nice arrow projectile path. All right, excellent. Now, it would be nice to draw the arrow back and show that projectile path getting larger as we're drawing the arrow, and maybe we could fire the arrow in the middle of that drawing arrow animation, and it would fire a bit slower, but if we wait until the arrow is fully drawn back, we could fire at a maximum speed. And the Sparrow Paragon Asset Pack does in fact have a drawing animation. If I go to Paragon Sparrow, Characters, Heroes, Sparrow Animations, and search for Draw, there is this drawback animation. So you could see how this projectile path could be applied to that. We could simply change that arrow speed as we're drawing this back. Perhaps we could use a timeline, or we could see how much of the animation has played, maybe a percentage of the animation, and once we reach the end of the animation, our arrow speed goes to max. So there's lots of possibilities there, and depending on if I get any requests for that, maybe I'll cover that. Leave a comment below if you'd like to request a new topic for a tutorial series. So that's going to wrap this up. Excellent job. Go ahead and join my Patreon if you want to get a project file that contains these assets, that spline mesh, our little cylinder, and the material if you don't want to go and create a UE4 project with that VR template and get those and then put that beam mesh into Blender and scale it up. I'll give you all that stuff if you join my Patreon, so do that if you're interested. If you like this video, go ahead and like and subscribe and hit the bell for notifications so you can know when I have a new video coming up. And as always, thank you all so much for watching. I hope you enjoyed this. I'll see you in the next video.